This is Accelerated Geometry, section 7.5. The topic is proportional segments between parallel lines. Okay, what do I have here? I have a triangle, and I notice that the slope of DE and the slope of CA are the same. So that means this line is parallel to this side of the triangle. So I think if a line is parallel to one side of a triangle and it passes through the other two sides, then it divides the other two sides how? Okay, here we took AD and divided it by DB. I get 0.66. Here we take EC and we divide it by the measure of BE, and we get 0.66. So it seems that if a line is parallel to one side of the triangle and passes through the other two sides, then it divides the other two sides proportionally. So that is conjecture number 64. Conversely, I don't have this listed on the conjecture list, but it goes the opposite way. Conversely, if a line divides two sides of a triangle proportionally, then it is parallel to the third side. Okay, so here's a problem, and it says our lines M, which is over here, is M parallel to FL. So I say, well, I just learned this conjecture. If a line divides two sides of a triangle proportionally, then it is parallel to the third side. So these two lines will be parallel if I can set up a proportion between the two sides, a ratio of the left side equal to the ratio of the right side pieces. So that's what I did here. I said, if I take 48 over 56 and say it's equal to 54 over 63, I should get a true proportion. So when I took my calculator, I divided these two numbers, and then I divided these two numbers. I also could have cross-multiplied to get the same numbers on each side, but I divided, and I got these two values, which are identical. So therefore, line M is parallel to that line segment FL. Okay, next conjecture is 65. If two or more lines parallel to one side of a triangle pass through the other two sides. Okay, so what's happening here? I have three lines in my drawing here, actually two that are parallel to this third side, so it ends up being three parallel lines. They break up the triangle into these pieces, U, R, O, V, T, and Q. If two or more lines parallel to one side of a triangle pass through the other two sides, then they divide the other two sides how? Okay, so here I took U over R, and I got 1.18. And on the opposite side here, I took V over T, and I got 1.18. So these two pieces and these two pieces created as ratios, as fractions, will be equal to each other. Okay, then in the next one I said U over O, so that M stands for the measure. So the measure of U, this guy, over the measure of O, the bottom guy. Okay, so U and O, I put those as a fraction. They turn out to have a value of 1.31 when I divide them. And corresponding to that would be V over Q. And when I took V over Q on Sketchpad, I also got the same ratio of 1.31. Okay, I also could have gone R over O is equal to T over Q. I don't have that one listed here, but I would have gotten identical ratios for each of those also. And then for the last part, we said U over V and R over T and O over Q, all of those ended up to have the same ratio. So if two or more lines parallel to one side of a triangle pass through the other two sides, then they divide the two other sides proportionally. So that is conjecture number 65. Here's an example of that. It says R, S, and OU are all parallel to each other. So this is parallel to this, is parallel to this. Okay, I want to find what M is and what N is. So I think I'm going to have to do these in two different ratios. So let's see what we did here. If two or more lines parallel to one side of the triangle, that's what I have. If they pass through the other two sides, which they do, then they divide the other two sides proportionally. So this is what I set up. 3 over M equals 2 over 4. Cross multiply, you get 2M is 12, M is 6. Okay, now I want to find out what N is. There are a couple of ways I could have done it. Since I just found out that this was 6, I decided to go 6 over N is equal to 4 over 3. Cross multiply, 4N equals 18, divide by 4, N is equal to 4.5. Now I have a warning here. Be careful, be careful, be careful. Using parts of the triangle, I can find out what X is. Okay, so I set it up as 4 over 12, because these are parallel. The parallel sides break this into two parts. 4 over 12 equals X over 18. Cross multiply, divide by 12, I get X is equal to 6. Now, if I want to find A is a side of the triangle. It is not one of these side pieces. It is a side of the triangle. So using sides of the triangle, this whole side of the top triangle A over this corresponding side of the big triangle, which is 20, is equal to 4, which is the right-hand side of the top triangle, over the right-hand side of the whole triangle, the whole side. Okay, so A over 20 is 4 over the whole thing of 16. So when you're using sides, you have to use sides for all of the numbers. So a common mistake is for kids to say A over 20 is equal to 4 over 12. No, because A is a whole side and 20 is a whole side, I have to use 4 as a whole side and 16 as a whole side. Okay, this one over here with the parts, it was okay to do because X is just a part of this big triangle, which is cut through by a parallel line. So I can say X over 18 is 4 over 12, just part. Okay, now there is one more thing that I want to do, and that is to talk about a construction. So I've solved it over there. So here is a construction, and what's happening here is they take this segment AB and they want to break it into 3 pieces. So what they do is they create this extra line. They just draw in this extra line straight, not crooked like I'm drawing it. Okay? And then with that extra line drawn in there, they open up their compass, and with any opening they want, they break it into 3 parts. They connect that last arc intersection to the end of the triangle. And now, if they want to break this AB into 3 parts that are equal, here are 3 parts that are equal. So what I need to do this are lines that are parallel to that third side. So here they are constructing those parallel lines. They stab in here and they go through there. Okay, and then they want to copy that here. And then they go, how wide is that open? How wide is this open? Then they can create that. And then they copy it here. How wide is this open? How wide is that open? And they can connect it there. Now, I'm going to actually do that a little bit better. I'll do that by going over here. In the last lesson that we did, section 7.4, the question was that they had a line segment that they called AB. And they said, break it into the ratio of 2 to 3. So we did that by creating a long line here, and then we broke that line, that piece, into 1, 2, 3 equal pieces. With the compass open 2 units, we stabbed in here and made an arc. With the compass open 3 units, we stabbed in here and made an arc. And then that created a triangle in which we did an angle bisector. And that broke it into the ratio of 2 to 3. Okay, now I'm going to do the same thing, break it into the ratio of 2 to 3. But what I'm going to do here is I'm just going to create a segment. And I'm going to, nope, I'm not going to do that. That's the other method, sorry. I'm going to build that segment onto here. So I'm going to take a ruler and make a nice long segment. Doesn't matter how long. Open up my compass to any opening I want. And I'm going to open it up to the addition of those 2 numbers, 5 parts. So I'm going to stab in and say, okay, with any opening I want, there's 1 part. With the same opening, stab in here now. And I'm going to continue to do this. There's 3. Stab in here, that's 4. Stab in there, I got 5. At the end of 1, 2, 3, 1, 2, 3, 4, 5 sections, I will take a ruler and connect it to B. Now, I want the ratio to be 2 to 3. 2 to 3. So here is 2, and then here would be 3. So this is the point. This is where the parallel line has to be in order for me to break this into the ratio of 2 to 3. So I want a line here parallel to this side. Now, how do I do that? I'm going to copy this angle. So I'm going to use equal corresponding angles. I'm going to stab in here and go across, stab in here, and with the same opening, go across. I'm going to go back and open up my compass this wide, and I'm going to stab in here with the same opening, chop off this, and then connect from here to that arc intersection. And that would break this into the ratio of 2 to 3.